Okay, next we will do the we will discuss on the general model of amplifier. So first of all, before that, we just define what is amplification and what is amplifier. Amplification is the process of increasing the power, voltage, or current of an AC signal by electronic means. And the amplifier is the device or the circuit used to perform the amplifying function. Okay, so there is many classification or how you can classify the amplifier. So in terms of the big group of amplifier, the amplifier can be classified into two groups in terms of the signal magnitude. So the first one is small signal amplifier. So small signal amplifier. Okay, small signal amplifier, and the second one is large signal amplifier. Small signal amplifier, for example, the circuit that you want that used to amplify your for example your ECG. ECG is the signal from your cardio or from your heart. This is for medical application. So this one is using small signal amplifier because it amplifies the very small signal. And then the second one is large signal amplifier, or we call it power amplifier. Power amplifier can be seen for in application of telecommunication when you transmitting the signal. So since you want to transmit the signal to a very distant place, so you need to add more power to the signal. So this is where we need to have the large signal amplifier. Okay, this is in terms of signal magnitude. And then the classification of amplifier in terms of the input, its input and output quantity is can be classified as follows. The first one is voltage amplifier. Voltage amplifier is where the input is, so voltage amplifier is the input is voltage, the output is voltage. So we amplify the voltage input become the output voltage. And current amplifier amplify the input current become output current. So the both input and output is in form of current. And then the third and fourth one is called it has a different quantity or different quantity of input and output. The third one is transconductance. Transconductance is the input is voltage but the output is current. So this is transconductance amplifier. And transresistant amplifier is the input is current and the output is voltage. So how you can relate the name of transresistant and transconductant is actually you can relate it with the equation for resistance and equation for conductance. For example, the equation for resistance is R equal to V over I. So this is equation for resistance. And the transresistant amplifier, the gain is, let's say I put this is IR, the gain is output is voltage, input is current. And then you see the relationship between voltage and current is the same. Same goes to the transconductance. Conductance is inverse of resistance. So this is I over V. So A, let's say I put this IC, the conductance is I over V. So this is how you can remember the relationship between the gain and the input output. Okay, when we talk about the general model of amplifier, there are several parameters that you need to consider. So the first one, since this is amplifier, so we need to consider the gain. How much the output will become bigger, or how much the output is enlarged compared to with respect to the input signal. And then the second and the third is the impedance of the amplifier itself. So we have the term called input impedance and we have the output impedance. And then the last one is operation bandwidth. Operation bandwidth is relate to the frequency of signal. Okay, so you need to understand that for the electronic device that handle the AC signal, the performance of electronic device depend on the frequency of the signal. So sometimes some circuit cannot handle the very fast signal, or sometimes it cannot handle the very slow signal. So this is called operation bandwidth. So amplifier, it should define what is the bandwidth, what is the maximum frequency and minimum frequency that it can handle. Okay, so first the gain. So the gain is the ratio change in output to the change of input. So output over input. So if we consider the voltage amplifier, okay, and then we have the input voltage. So an amplifier, we have the input port and then we have the output port. For every port we should have another reference port. So that's why we can have the plus minus here. So the input port voltage at input port denote as Vin, and output voltage at output port is denoted as Vout. So the gain AVA is equal to Vout over Vin. Okay, so if the amplifier is current amplifier, so it should be no Vin, should be In and Iout. Okay, so for now let's consider the voltage amplifier first. Okay, so you know the gain is dimensionless. Okay, this is the statement applicable for voltage and current gain. Okay, so the dimensionless, the word dimensionless means there is no unit, because for example, the gain for the voltage is output voltage over input voltage. So voltage over voltage, so the unit of voltage is cancelled out, so there is no unit. So if the gain is 10, for example, gain is 10 equal to 10, so means that the output is being amplified 10 times. 10 times. No, there is no unit. But we can use a unit called decibel or dB. This is the unit usually you need to describe the power or the magnitude of signal. Okay, how we can convert the gain to dB or decibel is by using this equation. If the gain is voltage gain, so you need to 20 times log AV. So if the gain is 10, so the AV in dB is 20 log 10. So log 10 is 1, so equal to 20 dB. Okay. So if the gain is 100, so log 100 is equal to 2, you'll get 40 dB. So the current gain also the same equation for voltage gain, but the power gain, the equation is 10 times log A voltage gain times current gain, because power is equal to PIV. Okay, this is how you can change the gain to the decibel unit. Okay, and then next we have the amplifier. So at the input port, usually we will apply the AC signal. So AC signal come from the source, and then every signal source has internal resistance. So we have internal resistance. So usually we put it RS or R6. Let's say I put RS or R6, R signal. So if the voltage is the signal source has the internal resistance, so there is two ways. If the source is the voltage source, you can use a Thevenin equivalent voltage circuit. If the source is current source, so you can use the Norton equivalent current circuit. So this is the source, the loop of the source, how the circuit. So we have the Vs and then in series with source resistance, and current source is the current source is parallel with the source resistance. Okay, and then at the output port, usually we will connect the amplifier with the load. Okay, so because amplifier is used to supply to power some kind of load connected to its output. So the load may be a speaker, antenna, siren, or any instrument. So usually this load is represented by the resistance called RL. Okay, now we have amplifier and we have the source. This is our signal. So I missed this one. And then we have at the output port we connected to the load RL. So if we supply the Vs, and then we know we define the input voltage at the amplifier as Vi. So the question that you need to consider is the Vi is equal to Vs. So means that if we apply the sine wave, the peak voltage is 10 volt, will the input the voltage at the input is the same signal? So the answer is not. So the Vi usually is not the same value as the supply, because we have the internal resistance here, R signal. So there will be a voltage drop here. So the Vi will be slightly lower than the Vs. Okay. So how and then beside of our signal, so we also have the internal resistance for the amplifier. So this is called input impedance. So input impedance is a total equivalent resistance seen at its input terminal. Okay, so this is the measured or the analyzed resistance from the input terminal. Okay, so this is defined as a Zi. So how the Zi, and then since we have the Zi here, so the Vi can be analyzed using the voltage divider. You can use the voltage divider. So Vi is equal to Zi over Zi plus Rs Vs. Okay. And then we have this one. And then the model of amplifier need to represent the amplification process. So amplification is the output need to be bigger than the input. So and then the ratio of the output and the input is defined by the gain AV. So here, in order to represent this amplification, we use the AC source, the dependent AC source. So and then the AC source is dependent to the input signal. So you see here, the output voltage here is equal to AV/Vi, and then you know Vi is a variable which is reflect the input voltage. So the output amplifier will become AV times Vi. Okay, so that's why we can represent the amplification process using AC source dependent AC source. Okay, so same as the internal input impedance, we also need to consider what is the equivalent resistance seen from the output port. Okay, seen from the output port. This is what we call it Z out, or ZR or Z naught. Okay, Z out or Z naught is output impedance, is total equivalent resistance seen at its output terminal. So how the Z out can affect the value of voltage drop at the load is you can use the voltage divider. So VL is equal to RL over RL plus Z out, and then the apply voltage is AV VI. So although we apply, we have the output of the amplifier, the value is AV VI, but the actual voltage drop at the load still depend on the value of output impedance. Okay, now we have the complete amplifier model for voltage amplifier. So we have the input impedance, and then we have this one dependent AC source to represent the amplification, and then we have the output impedance. Okay, and then this is the complete connection with the source and with the load. So if you you can express, for example, what is VI as a function of Vs. Okay, and then you can express what is V out as a function of V in. So this can be done. This can be done using the voltage divider. So this can be done using voltage divider.